Welcome to Bug Banter with the Xerces Society, where we explore the world of invertebrates and discover how to help these extraordinary animals. If you want to support our work, go to xerces.org/give.
Hi, I'm Matthew Shepard in Portland, Oregon.
And I'm Rachel Dunham in Missoula, Montana.
Today, we will be taking a closer look at the monarch butterfly. We won't be talking about milkweed or nectar plants or the migration and overwintering sites, at least not directly. Today, our focus is on pesticides and monarchs. We've talked quite a bit about pesticides on this podcast, so our listeners will know about the importance of protecting habitat from contamination. Are pesticides a particular concern for monarch butterflies? What are the consequences of pesticide contamination to their habitat, and what can we do to provide pesticide-free habitat? To answer these questions, we welcome back Emily May, Agricultural Conservation Lead with the Xerces Pesticide Reduction Program. Emily works with farmers, researchers, and conservation professionals and agencies across the United States to reduce pesticide risks to pollinators and other beneficial insects, support the adoption of ecologically sound pest management practices, and expand high-quality habitat in working lands. She also supports Xerces staff by providing technical expertise that helps guide resources, outreach, and policy efforts. Welcome back, Emily.
Thanks so much for having me.
All right, we're going to dive right in. Pesticides is an all-encompassing term to include any type of killer, for lack of better words. They're insecticides that are meant to kill insects, fungicides kill fungus, herbicides kill plants. It seems obvious that insecticides are the most concerning to monarchs, but other pesticides have an impact as well. What will you be talking about today?
Yeah, absolutely. So insecticides, of all these pesticides, definitely pose the most acute risk, right? They're designed to kill insects. They're the most acutely toxic to monarchs, but herbicides, fungicides, other sides also play a role and can cause harm. Herbicides can reduce the availability of milkweed and nectar plants for monarchs. Fungicides are increasingly being found to have sublethal, below lethal effects on insects, can cause harm, especially when in combination with other chemicals. Thinking broadly, zooming back out, pesticides are really one of the top three stressors for the monarch. Monarch caterpillars rely exclusively on milkweed. Adults need a constant supply of nectar. And so if plants are contaminated, the butterflies are exposed to pesticides. And unfortunately, even habitat that can look from the outside to be ideal, lots of milkweed, plenty of flowers, can still pose hidden risks if pesticides are present in that habitat. And that might be reducing survival or interfering with monarch caterpillar development or making those insects more vulnerable to other stressors that they're encountering.
Yeah, we know there are lots of factors contributing to monarch declines. We've talked about monarchs pretty extensively on this podcast. And there's habitat loss and degradation, climate change, disease, and other variables. How does pesticides fit into that?
Yeah, all of those factors are important contributors to monarch declines, right? Habitat loss doesn't just mean the loss of milkweeds, although that's a really big one. It's also loss and degradation of overwintering sites. For the eastern monarch population, the forest groves where they're overwintering in Mexico. And for the western monarch, the groves of trees on the Pacific coast of California into Mexico. Climate change is affecting monarchs throughout their range, from the breeding and migratory range down to the overwintering sites. And then so are pesticides. So obviously, some of these factors are more tractable or more easier to address than others. Climate change seems like a much harder one to address than some of these other ones that feel like we can address them with smaller scale solutions. I think what's interesting to me about some of these drivers is that they haven't been static over time, right? So there have been studies looking at drivers of monarch declines over long time frames, looking at land use, looking at climate, and found different drivers over time. So from habitat loss, the loss of overwintering site acreage, to milkweed loss. In the 1990s, monarch declines were most strongly linked to breeding habitat loss, driven by the widespread adoption of glyphosate-resistant crops and the resulting loss of milkweeds from agricultural fields in the Midwest. Milkweed loss began earlier than that time frame. They've been an agricultural weed for as long as they've overlapped with agriculture, but that rate of loss increased precipitously in the 1990s as those herbicide-tolerant crops became widespread. We lost over 1 billion stems of milkweeds from the Midwest in that time frame. And then there was a paper that came out last year that looked at environmental drivers of monarchs and other butterfly declines in the Midwest. And they found a shift that as glyphosate use plateaued and milkweed loss plateaued in the Midwest, the monarch declines were most strongly associated with the county level use of neonicotinoid insecticides. So from about 2003 onward, it shifted from being associated with county level herbicide use to county level insecticide use, and especially neonicotinoids. So this is reflecting the widespread adoption of treated seeds, so seeds coated with neonicotinoid pesticides in the Corn Belt. And so coming back to your original question, which is where do pesticides fit into all of this? I think to recover the monarch, we really need to address all of these different factors. We need to restore and protect breeding and overwintering habitats. We need to reduce the use and risk of pesticides. And really, we should also be addressing climate change as quickly and effectively as we can, knowing that we've baked in a lot of impacts already and that recovery is going to have a real long time lag.
Yeah, that makes a lot of sense. It's interesting to hear sort of the history and how threats have sort of changed in their significance. And I know at Xerces, we've used that like term death by 1,000 cuts because we often think of these all kind of like individual threats and that's it. But they do, interact with each other in some sense of like you think of this monarch butterfly that can't find good habitat for overwintering, or it can, but then it's like a super hot year and that adds stress. And then it encounters pesticides and that adds stress. So you just think as humans, like when we're hit on all of these sides of different stressors, it has a different impact than maybe just one, where it's like, okay, this is hard, but all these other things I have. So it makes sense that we counteract that by trying to fight against all of them and not just one at a time.
Yeah, absolutely. I think what you just said rang a chord for me where, if you're an overwintering monarch in a grove that is hotter than usual and not quite right on the climate factors, you might be venturing out for nectar more. You might need to fuel up more because your metabolism is going faster than it should be in that time frame. And that might lead you to encounter more pesticides, whether it's from venturing down into the water in an overwintering grove in Mexico that might be having, upstream agricultural activities, bringing pesticides in, or if you're at a California site, venturing out for nectar and possibly picking up pesticides that are being used in a residential area around those sites.
So when we talk about the impacts of pesticides, there's both direct and indirect. And some of these impacts are overlooked because they're maybe not as obvious. You're not going out and directly spraying monarch butterflies. But can you explain all the pathways of contamination?
Yeah, I think there are kind of two ways to answer this question. So how do pesticides get into monarch habitat? And then how do monarchs actually get exposed to those chemicals? I think they're kind of two different things. So let's start with how pesticides get into habitat. As we all probably know, pesticides really don't stay where they're applied. They are mobile. Whether they're being used in agricultural landscapes or residential landscapes, many of the same chemicals are being used in both spaces. And so one of the ways that pesticides might reach habitat is through drift. So if a pesticide is sprayed, whether that's on a crop field or a lawn, droplets can travel through the air and land on nearby plants or soil. And so even if those plants weren't the target, they can still be contaminated. There's also runoff, which is a major transport pathway for pesticides, where pesticides move with rain or with irrigation water into nearby areas, places where milkweed grows. And so in both of those settings, systemic chemicals, those that are moving with water, are a big concern. So these are chemicals that can be absorbed by plants and move into the different parts of plants like leaves, stems, nectar, and pollen. These can come from, in agriculture, seed coatings on row crops, or in spray products or granular products that are applied to lawns or golf courses for grubs. So there's also in residential settings where we're making our pollinator gardens, there's this additional risk of bringing in systemic chemicals on pre-treated nursery plants. So plants that were treated for aphids or whiteflies or something else in the nursery setting, and then being planted out for pollinators in residential settings. Those residues may still be present in the plants. So the second part of that is when those pesticides are present in the habitat, how are the monarchs exposed to them? So that can mean having different pathways of exposure might have different impacts on the insect. So one of those would be direct contact. So something crawling on a leaf, a caterpillar crawling on a leaf, or an adult landing on a contaminated plant, or directly, exposed at the time of spray. That's direct contact. And then there's oral exposure. So monarch caterpillars are eating milkweed leaves. So if those leaves contain an insecticide or another pesticide, they're ingesting that chemical directly. An adult monarch might be picking it up from nectar and ingesting it that way. For caterpillars, oftentimes it's actually a mix of those two things, right? They're getting the contact on the outside of their body by walking on a plant that's contaminated, and they're also getting it by eating it. So there's also indirect effects. You asked about direct and indirect effects. One of the biggest things I think about there is with herbicides, where these chemicals are maybe less acutely toxic to a monarch than an insecticide, but they are affecting the growth and flowering of milkweed or other nectar plants, meaning that the indirect effect is that monarchs have lost their food source. And this has really been, as we've already talked about, a major driver of habitat loss for monarchs, especially in agricultural areas, but it absolutely also happens in cities and suburbs when you've got roadsides being managed with herbicides or parks being managed with herbicides or yards. And so I think overall, one of the things that makes pesticide exposure difficult to see or work on is that it's invisible. You can have a beautiful patch of milkweed or nectar plants that look like great habitat, but there's no way for us as humans to sense that those plants have been contaminated with a pesticide. I think if it were more visible, if it were more obvious to us, it would be a lot easier to intervene when we see that something is potentially affecting monarch survival. But pesticides are really just adding this layer of pressure to a species that's already struggling with a number of other factors.
Thank you for explaining all of that. So have all these different ways of exposure. What does that mean for the monarch? So let's say a caterpillar ingests these pesticides. Does it affect its growth? Maybe its capacity of flying? What does that look like in an anatomical or practical sense?
Yeah, that's a great question. So pesticide exposure can have a really big range of harmful effects. The dose makes the poison, and the dose can also lead to different levels of impact, right? So there are lots of things that might not kill an insect outright, which is what we look for generally in a lab test. If you're screening pesticides for their toxicity, you're looking for, well, how much does it take to kill this insect? But there's things that affect insects that are not just them dying from it, but might affect population growth over time. And some of those are really hard to characterize. But there some examples would be reductions in body size, reductions in wing length or longevity, slower larval growth and development. There was a study that found that monarchs exposed to common fungicides as caterpillars had smaller wings as adult, and as a migratory species, that can be really important for whether or not that adult is able to make it to where they need to go during their migration. So those are kind of a range of different impacts. We know that monarchs are vulnerable to a wide range of pesticides, but there's still a lot to learn because we don't have a lot of specific toxicity data for monarchs. Only a few chemicals have been tested directly on monarchs. We've probably talked about pesticide regulation on this podcast before, but I'm going to talk about it a little bit. Before a pesticide can be registered, manufacturers of pesticides are required to submit tests, a variety of different tests to the U.S. Environmental Protection Agency, EPA, looking at the toxicity to birds, mammals, fish, and insects, depending on the expected use pattern. And the main way that EPA assesses the toxicity to insects is based on a standard test of adult honeybees. But this testing might not be a great proxy for how monarchs are affected by different pesticides. Larval insects, native bees, other kinds of insects like butterflies might be more or less sensitive than adult honeybees to different pesticides. So we still have quite a bit to learn about some of these direct impacts on monarch caterpillars and adults. The other thing here is that those tests are primarily conducted on adult honeybees, but in sort of a short 48-hour observation period, looking at acute toxicity. Less common for EPA to require somebody to submit a test looking at different life stages. But we know that monarch caterpillars are especially at risk from insecticides, and chronic exposure can lead to some of those subtle effects that we often aren't looking for in those standard lab tests.
I know from my experience and from listening to you right now that pesticides are a complicated topic. Like with so many things, once you start looking into it, it becomes more and more nuanced and not as simple, straightforward as you thought it was. Like you say, it's like things are tested. Does it kill it or does it not? Does it kill it within a short period of time or doesn't it? And yeah,
Does it kill it the way you're expecting it to kill it? So what I almost said there, and I'll say now, is that there are a lot of important effects that are missed when toxicity testing only happens for this really short window of time and only focuses on adults. So there was research conducted by University of Maryland professor Niranjana Krishnan that was doing bioassays of pesticide toxicity to monarch caterpillars at different instars as well as monarch adults. But she identified this really important secondary mode of action. So the way a chemical kills an insect or affects an insect is called the mode of action. And she found this secondary mode of action for neonicotinoids on monarchs and some other butterflies as well, which is a disruption in molting at the final stage of larval development. So at the fifth instar, caterpillars that had been exposed to a neonicotinoid didn't successfully make it to pupation. And this was really unexpected. This is not how you expect this chemical to affect the insect. But this is sort of, a secondary mode of action. So not a nervous system impact, which is the primary impact of neonicotinoids on insects, but an inability to make it from larval to pupal stage. And there were no other symptoms observed in these caterpillars prior to their death from this, what's called arrested ecdysis, or an inability to molt properly. And this was the leading cause of death for these fifth instar larvae treated with a neonicotinoid, which is why it's really important for us to think beyond these short-term window acute exposure toxicity studies and look at those that are moving across life stages. I think about this a lot with a species like the monarch, which is migratory. Could there be carryover effects from larval to adult stages and then beyond, where generations later are being affected by pesticide exposure that happened the previous generation?
yeah. Wow. Like you said earlier, looking at the honeybee really doesn't give you the picture you need. Although I was also waiting for you to say it was arrested development that caused the problems for them, but I didn't. So, yeah, like you say, pesticides can impact monarchs in all their life stages, but also all across the landscape because they are a migratory species. And so we know that pesticide contamination can happen anywhere. And we often think of working lands, i.e. farms, forests, and those kinds of places as the biggest culprit and the ones that are, there's that classic, maybe stereotypical image of the big spraying machines going past or the aircraft flying over and the clouds of pesticides going out. And so that's what we think of almost immediately with pesticide contamination. But, and you've already hinted at this, what we do in our own backyards can be harmful. Maybe it's bad, maybe worse than that.
Yeah, monarchs are affected by pesticides in all kinds of landscapes, not just farms. Exposure can happen in gardens, roadsides, parks, anywhere monarchs are looking for host plants and nectar. So it's important for us to be thinking about pesticide use across landscapes, not just in agriculture. Farms, as you said, are often seen as this main source of pesticide contamination. And while they do account for a lot of pesticide use, and especially herbicides, urban and suburban landscapes can be just as problematic, especially when it comes to contamination of host plants. About a quarter of all insecticide use is happening in residential landscapes. And some of those residential pesticides might be applied more frequently at higher rates per acre and with less oversight than what we have in agriculture. So products like lawn insecticides, mosquito sprays, herbicides, these kind of pre-treated ornamental plants, all of those things can contribute to contamination. And I think what is hard about residential use too, for me to understand, is that many of them are applied preventatively or cosmetically, not because there's any real pest issue or problem, but just to keep things kind of looking nice and tidy. So contamination is definitely a landscape issue, and it's important for us to think about not just about where we add habitat, but how we protect it from exposure to chemicals in every setting.
I think for people who are professional pesticide users, such as a farmer, and it's a cost, it impacts their bottom line. They are probably more cautious and more careful about their decision making, and certainly the quantity that they put on, because every extra gallon costs money. And I think for gardeners, it's easy to grab a small container that doesn't cost many dollars and just squirt and squirt and squirt. So, I mean, are there any studies that show what pesticide contamination is like across the different landscapes?
Yes, there's studies that have looked at pesticide contamination across landscapes, but just a few that have looked specifically at plant contamination. There's more studies of water contamination than there are of plant contamination, and definitely few on butterfly host plants. The basic takeaway from some of those is basically everywhere we look for pesticides, we're finding them, and sometimes at concerning levels. So one example is Xerces conducted a study with collaboration from researchers in California's Central Valley, and we sampled milkweeds from a mix of different landscapes, from agriculture, from urban areas, natural areas. Out of the 227 plants sampled, every single one was contaminated with pesticides. And across samples, we detected 64 different pesticides, including multiple insecticides, fungicides, herbicides, even an adjuvant. On average, those plants contained 9 different pesticide compounds, sometimes up to 25. So I think what's difficult about that is that sometimes it's hard to know where that contamination is coming from. So one limitation I see with a lot of field research on pesticides is that many studies are only testing for a very small group of compounds. So maybe just the ones that they're expecting to find or interested in, like neonicotinoids. But in reality, there's a much broader chemical landscape out there that can be unexpected. So we have a study in press that was sampling butterfly host plants from 2 different urban areas. And we were surprised to find widespread contamination of these plants in residential areas with atrazine, which is an agricultural herbicide, not registered for use in residential areas. So we weren't expecting to find atrazine in this city environment. We don't know how far it traveled to be able to get into these plants, but it was there. So I think if you're out there thinking about conducting pesticide research, one recommendation I have is test for a broad panel of pesticides. Don't just test for what you expect to find, but test for as broad a suite as you were able to sample for. And if we hadn't done that, we wouldn't have caught we wouldn't have caught atrazine. So yeah, if we only look for what we expect, we're going to miss a lot of what's actually happening out there.
Yeah, you don't always want to go out and only ask the questions you already know the answers to, right?
Yeah,
But
exactly.
yeah, I had heard from some of these studies how products are being found that the homeowner didn't know that was on the land. It wasn't something that they'd applied, and so these products are coming in from anywhere, from other places, whether that's from the farm field or maybe your neighbor. I know we've talked a bit about contamination of monarch habitats, and I'm guessing that the prime concern when it comes to contamination of plants is going to be milkweed for the caterpillars and nectar resources for adult butterflies. Is that right?
Yes. And I'd say of those, milkweed is a big concern because of the chronic exposure that a larval butterfly would face. So a caterpillar is on that plant, feeding exclusively on that plant for a long period of time. And that kind of chronic exposure can lead to greater impact than a monarch adult coming through and foraging on one contaminated nectar plant and then moving on and having more diversified set of plants that they're foraging from. So I think the host plants are where I really focus my attention in general, is making sure that the milkweeds or the other butterfly host plants are not as contaminated. One other thing I'll mention from that study we conducted in the Central Valley is there was one story from that that really highlighted the invisible risks from pesticides, which was we sampled milkweed in a colleague's yard in Sacramento. She had moved into this house and planted milkweed near her foundation. And this sampling event occurred, I think, 6 years after she'd moved into the house, 5 or 6 years. It turns out that the prior owner of that house, as they moved out, treated the foundation for termites or carpenter ants. And so the milkweed sampled next to the foundation had fipronil, which is the main ingredient in termidor, which is the termite treatment around foundation. And it's highly persistent. And it was still being found in milkweeds 5 or 6 years after it had been applied. My colleague had not applied that to the house. So that's something to be aware of. If you live in an area where termites and carpenter ants may be frequently applied, you've just moved into a new home, consider moving some of your host plants away from the foundation of the home if you don't know if that home has been treated around the foundation, because some of those chemicals are quite persistent and can be systemic and taken up into plants. So that was one really surprising and somewhat concerning story that we found from the Central Valley milkweed study that we conducted.
Yeah. No, it makes perfect sense that you would be most concerned about caterpillar host plants, because it's like for people, if we feed kids contaminated food, it could impact them for a long time. But as adults, if we just have one bad meal, we recover fairly quickly. But I was thinking more about the kind of the geographic movement of monarchs, because when I'm thinking about monarchs, I always think of them as something that actually connects us all. What we do in our garden could help or hinder the monarchs that someone a mile away, 2 miles away, 10 miles away is doing. But in particular, the monarchs, their migration is moving towards their overwintering sites. In a way, like with host plants and the larvae, the fact that monarchs hang out in these sites for months, are there particular pesticide concerns around those overwintering sites?
Yes, I think overwintering sites are a prime place where we should focus our attention when it comes to pesticide protection. Even though monarchs aren't really laying eggs at that time, few exceptions, they are still seeking nectar, and they're also in a particularly vulnerable state because there's hundreds to thousands of monarchs that are potentially affected all at once if they were to experience pesticide exposure. There was a really important example of why this matters that happened just this past year in Pacific Grove, California, which experienced a monarch kill incident at an overwintering site. The butterflies were found, about 200 out of the 2,000 butterflies present at that overwintering site were found dead or dying on a private property nearby on a lawn. And researchers from Xerces and USGS and volunteers from the Pacific Grove Museum were able to test some of those butterflies and found residues from 15 different pesticides in their bodies, including several pyrethroid insecticides at concentrations near or above levels that were known to be lethal to monarchs. So pyrethroids are a kind of insecticide that are commonly used in residential settings for a number of different things. They're the most common mosquito and tick control in backyards. They're also used for other nuisance pests like ants, other critters that people don't like having around their houses. Don't know why. But on average, each of those butterflies contained 7 different pesticides. So this paper just came out making this association. And I think it's just serving as an example of why overwintering sites deserve pesticide protection, as well as coordinated outreach and education to nearby residents. Many of those California coastal grove overwintering sites are surrounded by residential land in developed areas where pesticide use could be occurring by just private homeowners. Similarly, in Mexico, the eastern monarch overwintering sites are threatened by pesticide exposure happening upstream. So I think we absolutely should be concerned with when we have these huge clusters of monarchs that could all be affected at once, we should be taking steps to make sure that they are adequately protected.
And you mentioned it was pyrethroids that affect them in the Pacific Grove. But one thing I find about the pyrethroids is that they're often marketed as being natural and therefore safer because they're, to quote, plant-based, because they're a synthetic version of pyrethrum, which is plant-based. And so it's just one of those things, people may be using it thinking that somehow they are, quote, safer with air quotes.
Right. Yeah. Pyrethroids are the synthetic relatives of an organic insecticide called pyrethrins, which are derived from chrysanthemum flowers. So you might have someone market to you at your front door pyrethroids being these derivatives of chrysanthemum flowers, but they are synthetically derived and they are made to be much more stable and persistent in the environment than the original organic insecticide, which is highly toxic to a broad spectrum of insects, but breaks down pretty quickly in sunlight. So pyrethroids are not equivalent. That synthetic version lasts many days longer in the environment. And pyrethroids are one of the groups of chemicals that we know to be very, very highly toxic to the monarch. The monarch butterfly is very susceptible to pyrethroids. The other one that I would call out is chlorantraniliprole, which is a long name. It's a diamide insecticide. It has over 100 uses in agriculture and residential spaces, including as increasingly common lawn grub treatment. So if you're getting granules to throw on your lawn for lawn grubs, those may contain chlorantraniliprole, which is highly toxic to monarch caterpillars. 50 to 500 times as toxic to monarch caterpillars as neonicotinoid insecticides. So I think one of the things that I really want to emphasize is just using caution about what you're applying to your lawn or to your other areas around your garden, and not assuming that something is safe just because it says on the package that maybe it targets a particular insect. Typically, these things are not quite so targeted.
I'm glad it's you calling it out because I couldn't even pronounce that one. What was that? What was that one again, just so that our listeners catch it?
Chlorantraniliprole.
Okay, thank you.
So this conversation has been a bit of a downer. I mean, it's really hard to hear all of these sad stories, and it's hard to even grapple with like, how do we truly make an impact and reduce pesticides on the landscape when we're just one person? But the good thing about Xerces I really appreciate is that we're all about action and hope that there are things that we actually can do and we are having a positive impact. So that's the big question, right? What can we do? I assume that a lot of our listeners probably don't use pesticides, or maybe they won't after listening to this podcast. So if we're not personally using pesticides in our yard, let's start with our neighbors, for example. What if our neighbors are using pesticides and there's drift? Do you have any advice on how to have conversations with people in the community? We get this question a lot from folks.
Yeah, I think this is a great question. And I think a lot of people feel stuck here, right? If you're avoiding pesticide use yourself, but you're surrounded by neighbors, whether you're in ag or residential spaces where chemicals are being used. And I think the first step is just having that conversation, whether it's with your neighbor or your HOA or your city or county parks department. A lot of people don't realize that their mosquito spray or their lawn treatment could be affecting your pollinator habitat. And so sometimes just having that initial conversation can open the door. Sometimes not. We all have, experience with maybe a neighbor that isn't going to be receptive to that conversation. So if you don't want to have the conversation, there are some other strategies to help protect your habitat. Things like planting some kind of a vegetative buffer. So this was like a drift buffer, basically, shrubs or trees or dense stand of tall native grasses that can act as a windbreak and help filter out the drift that's coming in from your neighbor. So if you're planning a pollinator garden bed, try to place it as far as possible from areas that you know are being treated around you, whether that's the crop field nearby or your neighbor that's getting twice monthly sprays from Mosquito Joe. So consider buffers both as far from the areas that are being treated as well as those vegetative type buffers to capture drift. And I think, it's important to know that you're really not alone in this. There are many other people experiencing this same problem. So look for community in this, whether it's your local native plant group, a conservation organization. Joining forces can help figure out how to approach that conversation, figure out if there's kind of a local resource you could create on it, and how you can amplify your impact in community with other people who are concerned about the same issues.
That's a really good suggestion. In terms of, you've talked a lot about community, are there any local government recommendations you can make to make change in policy?
Yeah, so this is a great question, a really important one. I think it can be a real downer working on pesticides, right? But I think one of the things I want people to know is that individual choices matter, individual habitats do matter, and system level change is also important at the same time. But your voice can also matter there. So there's many ways to help monarchs and other pollinators, and some of them are advocacy and policy related rather than planting a new garden. So a major action that people could take would be starting to ask questions about how public lands are being managed around them. That's if your neighbor is not receptive to a conversation, maybe look at parks or schools or roadsides, city landscaping around you, and start to ask questions about what pesticides are being used, how often are they being used, why are they being used. There are communities that have adopted pesticide-free policies for their parks or for pollinator habitats, or restricted the use of certain high-risk chemicals. So if your city or county hasn't taken those steps yet, be the advocate for change. Ask for integrated pest management policies that are prioritizing prevention and non-chemical methods first. So there are resources for this with Bee City USA. There's an IPM toolkit that you can help your city or your county take those steps. And so I would ask you look there. When it comes to larger policy, realistically, the only way that we are going to get landscape scale pesticide reduction is through policy, more effective regulation. Policy change isn't going to happen on its own. It happens when people push for that kind of a change. So whether it's with your school or your city, your state, et cetera, your voice matters on this. It also matters on the individual site level, right? A lot of the work that we do focuses on protecting one habitat at a time. And I think that effort is also really important. It really adds up. So there are many ways to be involved. There's many ways to contribute. I think the last one I'll mention is community science efforts, which are not policy, they're not building gardens, but they are really important for tracking monarch trends, milkweed trends, understanding habitat. So projects like, depending on where you're located, the Western Monarch Milkweed Mapper, the Western Monarch Counts, Journey North, other community science efforts are really critical to understanding population trends and habitat availability. And they are very reliant on everyday people to volunteer their time. So wherever you are, there's definitely a role to play and to be part of the solution, and the better chance we have with more people to turn things around.
I love those suggestions. Thank you for all of that. Definitely brings me hope, and knowing that a lot of people are out there doing this awesome work, and all the listeners listening to this podcast who are interested in this topic and making a difference. Are there any good resources for information in general on pesticides, how to talk to your nursery that people can use?
I mean, not to be biased, but the Xerces Society has a wide range of free and science-based resources on all of those questions, including planting guides tailored to region, nectar plant lists, advice on protecting habitat from pesticide contamination, which you can find at our website at xerces.org. There are other groups that have resources on monarchs. U.S. Fish and Wildlife just put up a page as part of their whole listing process for the monarch butterfly that has resources available. Monarch Joint Venture, CEC Tri-National Monarch Knowledge Network has a page on monarchs. So lots of resources available, but I would start with the xerces.org resources for your region.
I'm all about shameless self-promotion. Yeah, well, Emily, this really has been fascinating. I've been around for a while and have, some of these concepts, some of these things that I was aware of, but to have this opportunity to dig more deeply and dive into more detail has been really excellent. So thank you. Thank you for that information. Thank you for your knowledge. Thank you for your work. Thank you for your time today. As we wrap up, we have a couple of regular, hopefully simple questions for you. If you could see any bug in the wild, what would it be?
So I struggle with this question because there's a lot of bugs I want to see. But I think if I were to pick one, I really want to see the synchronous fireflies. And I know there's synchronous fireflies in different places around the world, but the one that's most convenient would be in the Great Smoky Mountains, where I spent some time in my high school years, but didn't know about them at that time. And I just read a lovely book called Night Magic by Leanne Henyon, based in Boone, North Carolina. She talks about these synchronous fireflies, where every year for just a couple of weeks, they're putting on a light show, thousands of fireflies flashing in sync in perfect rhythm. I would love to experience that in person.
Just individual fireflies are magical. So trying to imagine everything everywhere at once. Wow.
Our last question, we sort of had to come up with one because you've been on the podcast a few times and we've kind of asked you all of our questions. So we're going a little bit broader here beyond just invertebrates, because invertebrates support vertebrate life. They're very important for really everything on Earth. So what has been your most memorable experience with wildlife?
I think I would have to go with a trip that I took to Yellowstone National Park when I was around 8 years old with my mom. We went camping. And we were out driving around and we saw lots of people pulled over on the side of the road. And of course, it was a grizzly bear that was charging an elk. So I got to see a grizzly bear take down an elk on the side of the road in Yellowstone National Park. And then later, I went to the gift shop with my mom and got a stuffed grizzly bear. And that grizzly bear lived with me for many years. And now my son sleeps with it at night. So it's still around. And I still think about that. And the original question I think you had was about my most memorable experience with an invertebrate, which unfortunately was a stinging insect. So I'm not going to share that story. But I'm going to tie the grizzly bears back to invertebrates because, as it turns out, grizzly bears also eat a lot of invertebrates. You might not know this, maybe you do, but moths are essential food sources for grizzly bears. There are miller moths that start their lives all over the country. And then as adults, they migrate to the Rocky Mountains and they shelter under rocks to get through the heat of the summer. And these little plant transforming moths are like little peanut butter balls. Their bodies are like 75% fat. And so a grizzly bear can eat upwards of 40,000 miller moths a day. They just walk through these rock fields, turn over the rocks, pluck out the miller moths, and they can account for something like a third of a grizzly bear's nutritional needs over the course of a month, which I just think is a super cool story. And maybe it's the miller moths that fueled that grizzly bear to take down the elk that I saw in Yellowstone. I don't know. But I didn't learn about the moth component of their diet for many years after that.
Yeah, I think the miller moth, we can tie that back to pesticides as well, because if I remember correctly, the caterpillar eats grasses, doesn't it? So it's
Yes,
considered
it's
a lawn
considered a
pest. So people treat their gardens to control the caterpillars that turn into the moths that fly to the mountains and feed the grizzly bears that tourists at Yellowstone can enjoy. So one more reason for no more pesticides.
It's all connected.
I love that story. Thank you for sharing that. And I'm glad that now your son is using that stuffed animal. And I'm sure it reminds you of that memory. And hopefully someday you can take him to Yellowstone and see a grizzly bear.
I sure hope so.
Well, thank you so much, Emily. This has been very informative, and I just am grateful for all the work that you're doing at Xerces and for the hope that you're spreading. And I think this information will be really helpful to folks and hopefully some good action items that people can do to make a difference. And like you said, each one of us can make an impact, and everything really, truly does matter. So thank you for your time today. It's been a pleasure.
Thank you so much for having me. It's always fun to come on Bug Banter.
Bug Banter is brought to you by the Xerces Society, a donor-supported nonprofit that is working to protect insects and other invertebrates, the life that sustains us. If you're already a donor, thank you so much. If you want to support our work, go to xerces.org/donate. For information about this podcast and show notes, go to xerces.org/bugbanter.